Alright, this is the beginning of our 1.4 notes, and it is on page 10 of your packet. Go ahead and fill these in. If you need to pause it, do that. This is the distance formula and the Pythagorean theorem. So the first example we're going to talk about is using distance formula. Actually, we'll use Pythagorean theorem since the graph is here. So we're going to use Pythagorean theorem first, and the way we're going to do that is graph these points. So 8, -2, and 2, -10. Alright, so there's our line. We want to figure out what's the distance between these 2 points. How long is that line? So the way we do that is what's called the Pythagorean theorem. So you're going to have a triangle. So you need to draw a right triangle. So start from one point and draw a horizontal line all the way even with the next point. And then draw down to the bottom point. I'm going to put my right angle in there. And then we want to figure out the length of these two sides. Can't count that length because it's diagonal, but you can count these because they are horizontal and vertical. So 1, 2, 3, 4, 5, 6 units long, and this is 8 units long. So we're going to use Pythagorean theorem. We don't know our c, that's what we're looking for, the distance. And we want to plug in 6 squared plus 8 squared equals c squared. 36 plus 64 equals c squared. When you add 36 and 64, you get 100. Make sure you don't make your final answer 100. This is c squared. We want to know what c is, the length of c. We do not care about c squared. So we have to take the square root to get rid of that squared symbol. So the square root of 100 is 10. So the length of this line is 10 units long from here to here. So remember your hypotenuse, your c, is always across from your right angle. So that's why we know to plug the 6 and 8 in here and leave the c blank because that's the side we're looking for. Okay, so that is that. So if you notice what we did at the end, we took the square root for here in the Pythagorean theorem. Distance formula is actually derived from the Pythagorean theorem because all it is the change in the x values squared plus the change in the y values squared, and then you take the square root of it. That's the same thing we're doing here. Our a value over here was the change in the x values. Our b value was the change in the y values. So that's the only difference. It's just it's a different form, but they're actually the same thing. It determines length. Okay? And now I'll show you an example with the distance formula. So I'm going to rewrite my distance formula down here. x2 minus x1 squared plus y2 minus y1 squared. So this is my x1 and my y1, my x2 and my y2. These can be interchangeable. You can make this x1 and y1 and this x2 and y2. That's supposed to be a y. It's kind of ugly little y. Here we go. But just make sure that the 1's are together and the 2's are together. Alright, I'm going to plug in my numbers. 0 minus 3 squared plus -1 minus 3 squared. Alright, we've got -3 squared. We do 0 minus 3. And -4 squared. Alright, the cool thing about this is the negative sign disappears because -3 times -3 is positive 9. And this becomes positive 16, which is really nice. So 9 plus 16 is 25. The square root of 25 is 5. That is the length of this line, or the distance between the 2 points. Alright, now we're on to page 11, and we want to solve for the perimeter of this triangle. So we want to find the length of all the sides. 2 of them are horizontal and vertical, so all we have to do is count. So you can just count from A to B, and it's 5 units long. You cannot count from A to D, so don't get confused on that. We're going to find the length of AB, the length of BD, and the length of DA. So AB is 5 units long. I'm going to go ahead and write that. And this just helps you keep it separated, and then at the end I'll add them all together. The length of BD is 1, 2, 3, 4, 5, 6 units long from B to D. Alright, and then it's up to you. You can either plug these 2 points into the distance formula, or you can use Pythagorean theorem to solve. And this is going to be a little more difficult than the Pythagorean theorem you saw before, because it won't end up simplifying into a pretty number, but that's okay. So I'm going to take 5 and 6 and plug them into the Pythagorean theorem. We're looking for our C because our right angle is across from the side we're looking for. So we've got 25 plus 36 equals C squared. And so we get 61 equals C squared, which I take the square root of both sides. So this, if you could simplify this radical, so if any perfect squares would end to that, or if you could make a factor tree and simplify it, then you would do that. You cannot for this one. You can't simplify the square root of 61, so it's just going to stay like that. So the square root of 61 here. And we need to add these sides together. So 5 plus 6 plus the square root of 61. You can only add the 5 and the 6 because they're whole numbers. But the square root of 61, you cannot add it. So you just have to leave it separated. So it's going to end up being 11 plus the square root of 61, which I know is not very pretty, but that is how you have to leave it. Okay? And that's going to be your final answer. Cool. Alright, let's find the perimeter of this triangle down here, so BCD. We already know that BD is 6 units long. We want to find DC, and we also want to find BC. Okay? So we can figure out this goes down 4 and over 3. The crazy thing about this is this also goes down 4 and over 3. So if we use Pythagorean theorem, we only have to do it once because they're the same numbers here. This is an isosceles triangle. They're the same length. So you're going to take 3 squared plus 4 squared, set it equal to C, which we actually did this one on the page before. So we've got 9 plus 16 equals C squared, 25 equals C squared, and the length of both of these are going to be 5 and 5. So this one works out really nicely. It's not blurry. Is that blurry? I can fix it. Maybe that's a little better. So 6 plus 5 is going to be your perimeter. 16 is your perimeter. Alright, now we want the length of the entire quadrilateral, so A, B, C, and D. And that's why I labeled this A, B, C, D as I went along, because now all we have to do is figure out that it's 5 plus 5 plus 5 plus the square root of 61. So 15 plus root 61 is going to be your perimeter. So the only one you're leaving out is the 6 because it is not on the edge of this quadrilateral. When people miss this question, it's typically because they add in that 6, even though it has nothing to do with the perimeter of the quadrilateral. Alright, so here's the advanced part of this. So we're going to move on into area, finding the area of ABD, which is this triangle up here. So this triangle up here. Zoom that out. For area, it's going to be base times height divided by 2 for area of a triangle, or 1/2 base times height. It's the same thing. We have to find our right angle. So it's the two sides that touch the right angle are going to be our base and height, because base and height always have to be perpendicular. So we're going to take 6 times 5 and divide it by 2. 30 divided by 2 is 15. Alright, and I'm going to go ahead and put these as units squared here. We don't know how many units they are, but we do know that it is units squared for area. Alright, for BC, this one's a little tricky. Excuse me, BCD. This triangle down here. For BCD, you don't have a right angle. So you have to figure out, since we have an isosceles triangle, works pretty well for us, because we can draw an altitude from the base of this triangle, which is 6 units long, up through the top. And that is going to be 4 units long from base to the top. And now our height and our base are going to be perpendicular to each other. So 6 times 4 divided by 2 will give us that area. 24 over 2 equals 12 units squared. And then if you find the area of the entire quadrilateral, it's just 15 plus 12 equals 27 units squared. Alright, and then this last page we're actually going to do together in class at some point, because it kind of takes a little bit of critical thinking, and I want you to think about it instead of me just giving you all the answers.